So let's talk about a problem of this nature. This is also from the 10.4 homework. This is similar, but slightly different compared to the previous problem. Let's read it. A rectangle is drawn so that the width is 14 inches longer than the height. If the rectangle's diagonal measurement is 26 inches, find the height. Now, the thing that I recognize about this that's so much different from what we had before is that, previously our question was telling us about the rectangle's size by way of the rectangle's area. The area is 12. But here, the rectangle's size is being described in terms of how long it is diagonally. So if I sketch this rectangle, width and height, the diagonal measurement is 26 inches. The diagonal measurement. Now, what's interesting about a rectangle is that if you draw a diagonal, something from corner to corner, it will split the rectangle into two right triangles. You have this right angle here in the corner, which means I think that this problem is probably ripe for the use of something like quadratic formula. Because I think that when we are translating this statement about the diagonal measurement into an equation, we use Pythagorean theorem. We're going to get something eventually that will require the use of quadratic formula. So base one leg w squared plus h squared equals 26 squared, or a squared plus b squared equals c squared, if you're more familiar with that. Finally, let's translate this shape into an equation as well. So what do you think will become of this first statement? W equals what with the height? 14 inches longer than the height. 14 inches longer, so let me increase the height by 14. Increase the height by 14 to get the width. All right. So here's the statement about the shape. Here's the statement about the diagonal. So let's try to substitute in for W its alter ego, h plus 14. Let's square that instead of squaring h, instead of squaring W rather. Now let's very carefully multiply this out. H plus 14 times h plus 14. Let's very carefully distribute that. H times h squared. 14 times h. 14 times h. 14 times 14. Then I can't forget the h squared from the back and the 26 squared on the far side of the equation. Now if I combine some like terms, h squared plus another h squared, 2 h squareds in total, 14h plus 14h, 28 h's in total, 196 here, and 26 squared. Let me do some work here on the side and the calculator. 26 squared is 676. Now, once again, we have a quadratic equation. So my first instinct is to get a 0 on one side of the equation. And that leaves me with 2h squared, 28h, and then once again, I'm going to go over on the side here and do this subtraction. This works out to be negative 480. Okay, so this is actually pretty lucky. This is better than I expected, because looking at all three of these terms, all three of these numbers have a 2 in common. So 2 can be factored out. And then I think if we're very lucky, we might have something that can be factored out. So what stands out to me about negative 240 is that it can be thought of as the product of 24 and negative 10. And those two numbers, 24 and negative 10, if I add them together, I get the positive 14 here. So we did turn out to be very lucky. This equation could be factored, and I can use zero product property to say that the h could be negative 24, or it could be 10. But just as before, you can't have a negative height. And so my final answer would be the height is 10.